All right. So one of the last things we're going to look at is how we can prove the vertical angle theorem differently. We did it doing transformations, rotations, and now we're going to look at using some of the theorems that we've previously talked about. So we have this flowchart proof right here, and here's our choices that we're going to fill in with. So let me go back to AgileMind. All right, so what we're given again is that we have two lines and they intersect at point E, and we're trying to prove that angle DEC, which is this angle right here, is congruent to angle AEB, which is this angle right here. So here's what we're given, that the lines intersect. So there's your statement and here's your reason. Remember, the statement's going to be up top and the reason's going to be down low. When I look over here, this subtraction property, substitution property, and linear pair theorem, those are all reasons. These three right here are statements. Let me click that. So when we're filling these in, these are what going to be listed in the top, and then these will be listed below. Okay, so the first thing we have is that angle AEB plus angle DEA equals 180 degrees. So angle AEB, which is this angle right here, plus angle DEA, which is this angle right here, equals 180. And we know that because they are a linear pair, and the linear pair theorem says that their angles add up to 180 degrees. All right. Now, what else we have is we have some angles that are set equal to each other. We have another set of angles that equal 180, and then we have what we're asked to prove. So we know what we're asked to prove is going to be the last thing in our proof. So I'm just going to go ahead and slide it down there. So now I've got these two things. Well, we've got one set of linear pair that equal 180. So this appears to be another set. So we have DEC, which is this angle right here, angle DEC, and angle DEA. So these two angles add up to 180 degrees. And we know that because they are a linear pair. The linear pair theorem says that they add up to 180 degrees. All right, so now we're going to take these two, and since these add up to 180 and these add up to 180, then we can use the substitution property, and we can substitute and say, all right, well, if this equals 180 but this equals 180, then they have to equal each other, and that's what this one is saying. Okay, we've got this right here, and then we've substituted that 180 with what 180 equals over here, which is the angle AEB plus the measure of angle DEA. Okay, and that's the substitution property. So what we did is we took the 180 degrees out and we replaced it with what 180 degrees equals, which is this right here. Now what we have is this equation, and I know it's kind of hard to tell. If you look at your note sheet, it might be a little bit easier because it's all written in one line. And so what you'll notice is that you have the same thing on both sides of the equation. We have this right here. And when you have the same term on both sides of the equation, they cancel out because you can subtract them and they cancel each other out. So these would cancel out. And so what we're left with then is what we're asked to prove. This DEC, angle DEC equals the measure of angle AEB. And so what we did was the subtraction property. So we subtracted that angle from both sides to eliminate those, and then we're left with what we were asked to prove. All right, so when you have a conjecture and you've proven it, now that conjecture becomes a theorem. So in your notes, you're going to fill in for number 8, theorem. Okay, so theorems are proven conjectures. So you have this conjecture that you made using inductive reasoning, and now you've proven it using postulates and definitions and properties and other theorems that you've proven. So here's our vertical angle theorem. if two lines intersect to form vertical angles, the angles have the same measure. And we've proven that, so now we can use it in other proofs. All right, so let's just quick review. When we were writing the vertical angle conjecture, okay, we were using inductive reasoning. So letter A should be inductive reasoning. Because remember, we were looking for patterns, and we noticed that it just kept, when we all measured, they were all equal. And then when you're proving the theorem, you're using deductive reasoning. All right. So the last thing, it just says, what did you learn today? Can any two angles that share a side and a vertex be a linear pair? Okay, so these two angles right here, they share a side. They share side BC. They share this vertex C, but these are not a linear pair. So just because they share a side and share a vertex does not make them a linear pair. Okay, they have to be a straight angle, which makes that 180 degrees.